So let's start by looking at what examples could look like. I could ask you to graph an equation. So at this point, I can throw any type of equation at you, and you should, once you practice this, you should be able to determine what type of graph it is. So the equation I've given you is 2y minus 4x minus 2 is equal to 0. It looks a lot like general form, but it's not, because the number in front of my x value, my a value, is over here. Remember, a is always attached to x, doesn't matter where it goes. It's a negative. Can't have that. But that's okay. I'm going to show you how to deal with that a little bit later on. But I first want to figure out how to graph this, because where do you even start? Well, with the practice you've done so far, you actually have a number of options. I'm going to show you what happens when you just plug numbers into the equation, make a table of values, that sort of thing. I'll show you a couple of other options as well, such as converting, because that's another really important skill to have with this. Let's start by plugging numbers in and seeing how that works. Where did all that math come from? It's not so bad. I've chosen easy numbers. The 2 points that I want to find out are my x and my y intercepts. So I set either x equal to 0 and solve for y, or I set y equal to 0 and solve for x. That always gives me 2 points, and that gives me 2 points that I can solve, provided I have a line that crosses both my axes. So the first thing I did was I set y equal to 0. 2 times 0 is 0, they cancel out. Minus 4x minus 2 is equal to 0. We do some algebra, you end up getting negative 4x equals 2. You divide both sides by negative 4, you end up getting negative 0.5 for x. Remember, we punched in 0 for y to start. So that means that my first point is going to be negative 0.5, comma 0. So negative 1 is here, 0.5 is here, that's on my x, and my y is 0, so that's my x-intercept right here. For my second equation, same idea, except this time I made x equal to 0. So 2i minus 4 times 0, we cancel each other out, minus 2 equals 0. Clean that up a little bit, you end up getting 2i minus 2 is equal to 0. Send that negative 2 to the other side, it becomes a positive, so you have 2i equals 2. Divide both sides by 2 to get y by itself. You get y is equal to 1, and that was when x was equal to 0. So my y-intercept in this case is going to be at 1. So x is 0 is on the axis, y is at 1. Point goes over here. You grab your ruler, hopefully you're using a ruler unlike me. And that's how you graph from some sort of line that looks like general form. Now, I pointed out that this isn't general form. That's because it isn't, okay? I'm going to rearrange the formula so it looks a lot more like the general form we saw here, where the x value is stated first. It's a good habit to get into. You don't have to if you don't want to, just like we did over here in this example. I'm going to do it so that it corresponds to what you've seen already. So it looks like this. So right up over here, doesn't really look like it changed much. I just swapped the position of the x and its coefficient, the y and its coefficient. So negative 4x plus 2y minus 2 is equal to 0. Looks great. The equation still works with a graph. It's not technically general form though, because my a value is not a whole number. It's an integer. So what I have to do to make it work is I have to flip that entire equation around. Very simple. Just flip every single sign that you see. You see a negative sign, it becomes a positive. You see a positive sign, it becomes a negative. With zeros, it's really nice because it doesn't matter. Positive 0, negative 0, it's the exact same thing. So we're going to flip all the signs and you end up getting something that looks like this. And that, applied pre-cal, is general form. Okay, you don't need general form to work with it, but that's when I ask for general form, that's essentially what I'm looking at. Now I mentioned there's other ways to solve this type of problem, and there are. At this point, now that you have all the equations, you need to practice converting between all of them. One quick way, and this is probably the way that I like to work with things, is I like slope-intercept form. It's the form that I use the most. So I need to convert this equation to slope-intercept form. What does that look like?